Hello students, I am Asif, teaching in the Department of Geography, Jamia Millia Islamia, New Delhi. Dear friends, today I will discuss a topic entitled Digital Cartography versus Geographical Information System. Before going to discuss the digital cartography, I will discuss with you the normal cartography. Then I will discuss with you the digital cartography and geographical information system. And we will also discuss the various components, various requirements for digital cartography and geographical information system. In the last, I will discuss with you few examples which we have drawn through the digital cartography and through the geographical information system. With these examples, you will be able to understand what is digital cartography and geographical information system. Dear friends, if I will start with the digital cartography, then it will be a little bit uncomfortable for you people. I should have start with the normal cartography or with the development of normal cartography. First of all, I would like to tell you in one line what is cartography. Cartography is basically the art of map making. Through map, we transform the three-dimensional earth into a two-dimensional plane sheet. Dear students, if we will look at the history of cartography, it was started by the earlier Greek scholar somewhere before 3500 years from the present. It was the work of Aristotle, Ptolemy and Eratosthenes who draw the grids of latitudes and longitudes on the surface of earth, divide the earth into northern hemisphere and southern hemisphere, and also draw the various climatic zone on the surface of earth. You know, Eratosthenes correctly measure the circumference of the earth. And you know, dear students, it was Ptolemy who draw a world map, or rather I should say, who draw a world map of the known world on the basis of latitudes and longitudes. Dear students, although his map was not correct, but his method of drawing the map was very much correct. His map was not correct because of the fact his drawing of latitudes and longitudes was not correct due to the restricted information available at that time. You know, travel was restricted at that time. So, on the basis of the instruments available at that time, his map was very good and a pioneering attempt. You will be surprised to know that Ptolemy's map was not known to the most of the history of human civilization. It was discovered only in 16th century. The discovery of Ptolemy's map in 16th century, the age of discovery and the development of printing brought a revolution in the field of cartography. Dear students, you know, in 16th century it was Mercator who drew a projection which we will discuss later on. But dear students, after the 16th century, in 17th and 18th century, we have seen a lot of development about the art of map making, or rather I should say about the cartography. It was extensively used in warfare and different expeditions and different discoveries in 19th and 20th century. Now I would like to discuss with you about the digital cartography and geographical information system. Dear friends, one thing which you need to understand and which you need to keep in your mind is that there are several requirements for digital cartography as well as for geographical information system. These requirements we will discuss one by one. The first and the foremost requirement is the selection of geodetic datum. Now friends, what is geodetic datum? In very simple language, I will say it is the referencing point around which we developed our projection. Basically, it is the referencing point around which we developed our other entities. You know, dear friends, North American datum developed in 1927, and on the basis of that datum, we have developed various topographical sheets throughout the world, and that remain available even up to the second half of the 20th century. But with the age of development, with the aid of remote sensing and satellite data, we have developed few more datums. You know, Dear students, United States of America, the Defense Department of United States of America developed several datums. They developed a datum in 1960, then again they revised it in 1966, and again they revised it in 1972. They revised it again and again on the basis of the new informations available through the satellite data. But the datum which we are currently using is the WGS 1984. This is the latest datum, this is the latest referencing point through which we reference our projects throughout the world. You can say it is the worldwide central referencing system. Dear students, we are also having the local datums, but local datums are being determined locally depending upon the local circumstances. Then the second important thing is the system of arrangements of latitudes and longitudes. The arrangements of latitudes and longitudes is known as coordinate system. Look at the map which is provided as figure 1 in your module. In this map, we will be able to explain you the latitudes and longitudes and equator and North Pole and South Pole, all these things will be clear with the help of this map. Let me draw this map for your understanding. This is the spherical earth, dear students, and a line is passing through this spherical earth that is known as prime meridian, and a horizontal line passing through this that is known as equator and divide the earth into northern and southern hemisphere. Dear students, the arrangement of parallel line on this globe is known as latitudes or parallels because they are parallel to each other. The arrangements of lines joining north and south is known as meridian or longitudes. The arrangements of latitudes and longitudes make a grid system throughout the world. Dear students, these are the imaginary line we draw on the surface of Earth to draw our projection for the sake of map making or for the art of cartography. Now I will discuss with you map projection. Map projection is nothing but the arrangements of latitudes and longitudes on the globe in such a way so that we can transform the three-dimensional Earth's surface onto a two-dimensional piece of paper. There are several map projections. I will discuss few of them in brief. First, I will discuss with you the cylindrical projection, then we will discuss the conical projection, and then I will discuss with you the zenithal projection. Dear students, in your module, look at the figure 2. In looking at the figure 2, you will be able to understand what is cylindrical projection, what is conical projection, and what is the zenithal projection. When we place the plane surface at different positions on the globe, then we classify these projections. Suppose here we are having a globe and I am placing a plane paper at the top of this globe, then it is known as zenithal projection. If I will place this plane paper at this angle or at this arm, then it is also known as the zenithal projection. When I will place a cone over this globe, then this is known as conical projection. And similarly, if I will place this globe into a cylinder, then it is known as cylindrical projection. Dear students, when we talk about the zenithal projection can be further divided into mnemonic projection, stereographic projection, and orthographic projection. What is the difference in between these three projections? Let me explain you. We can explain it with the help of a map which is being given as figure number 3 in your module. Look at the figure number 3. Here we are having a globe and a plane paper is tangent towards this end. If the light is coming from the center of this globe, then it is known as mnemonic projection. If light is coming from the opposite angle, then it is known as stereographic projection. And if light is coming from the infinity somewhere from here and the rays are parallel, then it is known as orthographic projection. Conic projection, when we talk about the conic projection is that when we place a cone on a globe and it will tangent somewhere in the middle, then the middle parallel or the middle latitude is known as the standard latitude. That is known as standard latitude because the scale is true only to this latitude. There are several types of conic projection, but we will not go into the detail. And I will discuss with you in detail the cylindrical projection. Cylindrical projection is what? When we place a globe into a cylinder shape. Look at the map. Here we are having a globe and we placed it in a cylindrical shape, then this area is tangent along this. The other area which is not tangent, scale will not true to these areas. You know, the Mercator draw his projection, very famous projection on the basis of cylindrical projection, where the arrangements of latitudes and longitudes is parallel and they are having equal space. The map which is shown as figure number 4 in your module is based on the Mercator's projection. You know, the arrangements of latitudes and longitudes are in grids of a square, meaning thereby this map is true to the scale only along the equator, but when we move away from the equator, the area is exaggerated, and it will be very surprised to know you that area is such an exaggeration that their size become larger several folds in comparison to their original size. But on the basis of this Mercator's projection, we have developed the modern projection that is known as universal transverse Mercator's projection. Before going to discuss the universal transverse Mercator's projection, I would like to discuss with you the transverse Mercator projection. Because on the basis of the transverse Mercator's projection, we have developed the universal transverse Mercator projection. Transverse Mercator's projection is the modified form of the Mercator's projection. You know, in Mercator's projection, we have placed the globe into a cylinder. But when we will rotate that cylinder, look at the example. I am drawing a map which by this map you will be able to understand how we draw the transverse Mercator's projection. It is also given in your module as figure number 5. Here we are having the globe, and here we are having a cylinder and we place this globe into the cylinder. But in transverse Mercator's projection, and you know, the area which are tangent near the equator is only true to the scale, but away from it, that is not true to the scale. But when we transverse it in a form like this. Look at this map. Here we transverse the cylinder. Earlier it was parallel to the equator or the latitudes. The area which was true to the scale was quite near to the equator. But when we transverse it, it becomes parallel to the meridian. It becomes parallel to the meridian, meaning thereby the scale becomes true along this meridian, and the area which is being marked by this meridian is close to the true scale. And we continue further rotate this cylinder over the globe. By rotating this cylinder over the globe, we get 60 zones, and that is known as universal transverse Mercator's projection. Dear students, the thing which is very important to note in this projection is that we do not map the world as a whole through this projection, but we map the world into 60 zones with the help of this projection, because even in 21st century it is almost impossible to draw a world map on the basis of a single prime meridian. So we divide the world into 60 zones having 6-degree east and west extension, and the prime meridian is passed through the middle of this 6-degree extension, east and west extension. In table 1, I have described the 60 zones of universal transverse Mercator projection. What is the limit of these zones? As you know, after looking at the table, you will come to know that it covers a 6-degree zone, and the prime meridian or the central meridian pass through the middle of this zone. So each zone is having its prime meridian, and on the basis of this meridian we draw the map of that particular zone. You will know, you should know, students, that our India comes in 43 zone of world geodetic system, and that system is being drawn on the basis of universal transverse Mercator's projection. After the projection, I would like to discuss with you scale. A map is a map when there is a scale on it. If scale is not there, then it will not be called as a map. Scale is what? Scale is the ratio of the space on a map that equally represent the space on the surface of Earth. Suppose I say 1:1 lakh centimeter, then it means 1 centimeter on map will represent 1 lakh centimeter on the ground itself. So without the scale, we will not be able to analyze, or we will not able to calculate the area of a particular map. So scale is an essential qualification as far as the construction of map in GIS and digital cartography is concerned. I have discussed with you the requirements for the geographical information system map making and also for the digital cartography. These were the essential things which are necessary for going through the map making. Now I will discuss with you geographical information system. Dear students, as you all know, it is a new technology. Geographical information system is a software designed to collect, store, analyze, manage and present the spatial data. It is a computer-based programming which can give the instantaneous answers of several problems which we are facing in the modern world. It can give the answer of the several complex questions. Geographical information system is a software in which we can put the data and can get the desired result of different types of problem which we are facing in the modern world. Geographical information system has two types of data, that is called vector data and raster data. When we talk about the raster data is about the phenomena, about different type objects present in association, and it can be represented by the pixel or by the hard copy, while vector data is about individual attributes. It can be represented through point, line or polygon. One more important thing which is being given in figure number 8 is the description of vector and raster data and also different GIS layers. You all know about the topographical maps. In topographical maps, we have all the information collected in one sheet, but when we talk about the GIS layer, we are having the several layers comprises of different information. Through these GIS techniques, we can club these layers together and can get the information. So these layers are containing the information about different aspects, about different attributes. When we talk about the role of GIS in map making, we can even produce the three-dimensional maps with the help of the GIS data, with the help of the GIS software. Here I have collected few examples for you. These maps which I will show you in this module are based on GIS data and also processed through the GIS software. Look at figure number 9. In figure number 9, we try to classify the soil on the basis of the quality of soil and the type of agriculture in this particular soil is being placed on the soil. By looking at the map, you will come to know that which area is more suitable, which soil is more suitable for the agricultural purposes and which soil is less suitable for the agricultural purposes. We have placed the agricultural field, the agricultural crops over the soil or the type of soil. So, it is very helpful in identifying the type of soil and which soil is helpful of what kind of crop. It can be also discovered with the help of the figure number 9. Another example of GIS mapping is given in figure number 10. Look at the figure number 10. It shows the distribution of symmetries in different parts of a region. By dot, you can see the symmetries available in different regions. And by the colors, you can identify the regions. The region which is having the darkest color is being the area which is having the largest number of symmetries. And by looking at the map, you can easily identify the area having the large quantity of symmetries and the areas having the medium quantities of symmetries and the areas having the low quantities of symmetries. Another example which I would like to give you is through the figure number 11. In figure number 11, you can identify the change which has happened in a region with the passage of time. There are two imageries in figure number 11. One imagery is of the period of 1951 and the second imagery is of the period of 1999. There is a gap of more than 40 years. What changes have been occurred during these 40 years? Look at the image first. In image first, you will see a lot of green area. A lot of greenery is there, and that green area is represented the availability of greenery, availability of natural vegetation, availability of the forest in this particular region. But look at the image of 1999. The green patches have reduced a lot, and that has been the area which is being reduced from the green become yellow area. Yellow area is the representation of the constructed houses or constructed area in this particular region. So, you can see how the change is taking place in the land use pattern of this particular region. A lot of green area was there in 1951 and that has changed to a lot of yellow region because yellow region is the representative of the constructive region. So, a lot of changes has been taken place during these 40 or more than 40 years. So, you can identify the change, you can find out the change direction through the compare of both these imageries. So, these three examples which I have given you represent the way in which we map the things on the basis of GIS software, particularly the software developed by ISRI, and that software is known as ArcGIS. Buffer analysis, proximity analysis and overlay analysis can also be done with the help of the GIS techniques. But since there is a shortage of time, we will not discuss this into the detail. Now, I would like to discuss with you digital cartography. After the launching of Landsat 1 in 1972 and 1974 Landsat 2, there is a revolution in the cartographic history of the world. We get the data through these satellites and divide and map the United States of America into the 7 zones on the basis of digital cartography or computer cartography. Computer cartography is not as modern as the GIS, but it is also the invention of the 20th century. There are several companies in the world like Microsoft, Sun, which have developed several software for the computer cartography. If we will compare the computer cartography with the manual cartography, then we can save a lot of time through the computer cartography. We can develop the expertise through the computer cartography. Manual cartography cannot be error free, but computer cartography if we can analyze the data in a suitable way, in a suitable manner, then the computer cartography or digital cartography can give us better results. I have brought 3 imageries and will give you the 3 examples, the 3 maps which we have developed through the computer cartography. I have brought these maps through the net and only to make you understand about the computer cartography. Look at figure number 13. It is a world map showing you the digital divide across the world. This map is showing the availability of computer per 100 of people. The area which is marked by the greenest color or by the darkest color are the areas which are having the maximum number of computer per 100 of population. Look at the area of North America comprises of United States of America and Canada, and then look at the area of Western Europe. These areas are marked by the darkest color, and therefore these areas are having the maximum availability of per 100 availability of the computer. But as we move eastward, the availability of computer per 100 population is start declining. This map is being constructed through the computer cartography or the digital cartography. By looking at the index, you will be able to understand what is the computer divide, and by looking at the map, you can easily identify the areas of those areas which are having high number of computers and those areas which are having the medium number of computers per 100 of people, and those areas which are having low number of computer per 100 of people. Look at the figure number 14. This figure is showing the different earthquake zones of the Kazakhstan and the distribution of cities in the Kazakhstan. The darkest red color is showing those areas which are having the earthquake of maximum magnitude, and the tone of the color and the shade of the color declining towards the green, and green areas are marked as the areas which received a minimum magnitude earthquake in this region. Look at the distribution of the urban areas, and that is being plotted through the dot. So, after looking at the map, you will be able to understand what are the earthquake zones of Kazakhstan and how the population or the urban population of Kazakhstan is being distributed. Now, last map I would like to show you in figure number 14 as the distribution of density of population in India. Look at those areas which are being marked by the dark color, like Bihar, like Bengal. These areas are having the maximum density of population, and look towards the south, we are having Kerala, which is also having one of the maximum density of population. By looking at the map of India, you will be able to understand what areas are having the maximum density, what areas are having the moderate density, and what area are having the low density. So, dear students, looking at this module, while discussing this module, I would like to say one thing, that digital cartography and GIS techniques are not competent to each other, but they are complementary to each other. We can work in digital cartography, we can work through the digital cartography as well as through the GIS, but GIS requires a lot of more skills as compared to digital cartography. I do hope that you people will be able to understand this module. Thank you very much.